Hey everyone and welcome. We're doing a data dive today, deep into DynamoDB land. I'm Jason Hunter, a solution architect with DynamoDB, and I'm with Rob.
Hey, I'm Rob McCauley, Specialist Solutions Architect for DynamoDB. Great to be here.
And we're going to be doing this show, I'd say about every 4 weeks. I'll be the host, and we have other hosts on other weeks. And we're going to be diving a lot of times on DynamoDB, right? The serverless NoSQL database that gives you low latency at any scale. And today, as a special kind of start, normally I'd be interviewing somebody about maybe a new feature of security or whatnot on DynamoDB. And today I'm going to interview you all in the audience. We're doing DynamoDB puzzlers. What we're doing is I'm going to present something that Rob and I have seen as we interact with customers. Some strange thing that makes us say, that shouldn't happen. How could that ever happen? That's impossible. Something like that. And then we figure out what's really going on and we kind of go, oh, that makes sense afterwards. And so throughout the year, I've been collecting these things, situations where I was a little confused about something or Rob was. And I'm going to present it to you. And in the chat, you're going to reply and try to help us figure out what's really going on. What's the reason for such a behavior as could happen? All right. So we call it puzzlers, a little bit inspired by Java puzzlers, which some friends of mine did in the Java space. And so that's our first puzzler. What is an Amazon DynamoDB design puzzler? It is something where I'm going to present, this is what's happening, and you're going to chat back to me and let me know why it could happen. It'd be kind of funny if one of these actually Rob and I didn't know the answer to. We snuck one in. We were stumped.
I get puzzled every week in this job. I tell you what. Yeah.
So that's what we're doing. All right, everybody ready? Here's the first one. I'm going to do it kind of like a dinner. All right, amuse-bouche warm-ups, kind of simple, get you in the groove, and then we're going to do some meatier entrees, and we'll end with a little bit of dessert. All right. Here's the first puzzle. Real life. I'm seeing 10,000 write requests per second, but I'm consuming 20,000 WCUs. Why would that happen? And actually, as a first thing, I want to know what a WCU is.
What's a WCU anyway?
We have a poll going on. Write your number 1, 2, 3, 4, and we'll be able to see your answer. It is either a worldwide crypto unit. I need some of those. A White Claw University. I need more of those. Write capacity units. Sounds sensible. Or waffle consumption units. That was my morning.
I vote for 4.
Are you hungry? I think 1 is most lucrative.
It could be.
So we'll stand by. So 4 White Claws got a lead. What it is, should I tell people what it is? I think y'all figured it out. It's a write capacity unit. And I kind of put this forward as a test, like, see, are we ready to do DynamoDB? If this is your first exposure to DynamoDB and you're figuring out how do I spell DynamoDB, this talk's going to teach you some things, but it's going to go pretty deep pretty quickly. I just want everyone to be aware of that. All right. So write capacity units. It's the way that we do billing. So Rob, what's the obvious answer for this one? If we go back to the 10,000 write requests.
Yeah, there's a couple things that come to mind, Jason. I mean, the write capacity unit is 1 kilobyte unit. So I'm guessing maybe there's 2 kilobytes of data being written for every write.
Right, that's the classic one. That's what I thought first, because 10,000 requests, if each item is between 1 and 2 kilobytes on average, then that'll burn 20,000 WCUs because you get, 1 WCU for an item up to 1 KB and 2 up to 2 KB, 3 up to 3 KB. And what's interesting about it, though, if we go back to the slides, is I looked at the table's average item size and it was well under 1 KB. I thought, well, how, like, just, does that make any sense? What could that be?
I don't know. What do we think? Maybe could be an index there. Maybe there's like a global secondary index that's also consuming write capacity. Yeah,
you could. That's a common thought too, right? And so some people are saying, no, what are we talking about? We're deep diving on DynamoDB, learning DynamoDB by talking about situations where we see something that's surprising, learning what actually was going into that, and then along the way going to learn a whole bunch of different things about how DynamoDB works. Right now we're talking about write capacity units. So what's interesting is that you think it's a GSI, but a GSI and a base table, GSI is a global secondary index, it consumes from a different capacity bucket than the base table. This is 20,000 against the base table. So what could be doing that?
How about the local secondary index? That's part of the base table, isn't it?
That's it. Could indexes have something to do with this? Right. So we have global and local secondary indexes. Local secondary indexes are written along with the base table and consumed from the same capacity pool as the base table. So this indicates very likely someone has an LSI on the table. Now be careful with LSIs. You don't generally want them. You'd rather have GSIs. I just want people to know that. Its advantage is that you can do transactional consistent reads if you do a write to the LSI, but that's its only advantage. Otherwise, one of the downsides actually is that it consumes the same capacity as the base table. You usually want to spread that out. Here's another one that stumped me once. I have global tables and the write rates across the regions don't match. That's surprising because what are global tables? Global tables are, I have more than one region. I do a write in one, it updates in the other. So you'd think that a write, a write and a write. It's active. So any write to region A replicates to region B, back and forth. So why would they not match if every write in one region writes to the other region?
Yeah, you think a write to one should be a write to all. They should be the same, but
I'll give you hints.
What do you think?
I'll build you up for some hints. Could it have to do with TTL? What's TTL? TTL is time to live. With TTL, you set an attribute that gives a time when that item can be deleted. And what's nice about it is it's free. So you say at this point, this item is eligible for deletion and it'll be deleted, not maybe immediately, but shortly thereafter. And it doesn't cost you anything. But with global tables, you gotta be a little careful because the TTL delete in one region will be free, but it'll replicate immediately to the other side. That one's not free. Something to be aware of. If you're using global tables, be aware that you have to be able to have separate write rates. One reason is the TTLs.
Could be something else.
Hints.
What else?
Failure.
Yeah, replication could be paused right now. Maybe like a ship dragged its anchor across like the fiber under the ocean or something.
Seems to happen too often. So you sever the net, writes on each side will propagate. As soon as the network's back, they'll go. But if I've been accumulating writes here and accumulating there separately, they'll cross and you'll see for a while different write rates. What if I update and don't actually make a change? What does that mean? Like, what happens if I write an item, but like I set X to Y and it was already Y?
It's already Y. I think you'll be charged a write unit on the local side, but it won't need to replicate anything. So there you go.
Same with streams too. If you know DynamoDB streams, nothing goes into the stream if you don't actually make a change. So you can do a write that won't replicate anything because there was nothing to replicate. We don't waste our time.
I can think of another one.
You can? Is it the one I just pointed at?
Hey, good thinking. Conditional expressions. Yeah, like update this if my checking account balance can afford it. Otherwise, don't do anything. That's going to charge a write no matter what, even if it fails.
Right, exactly. So a condition expression on a write, you can say only accept the write if a certain thing is true. But there is a cost to that even if you get rejected. And so that's another one that can happen. So there's a wide variety of reasons that could happen. Here's another amuse-bouche one. I want a downstream client to do bulk reads, but limited to a certain amount of read capacity. And I don't want to risk throttling other users.
Well, that's a good one. Yeah, we don't want to take away from production traffic. We do want to maybe do like some analysis or separate job. I think, well, the read capacity will, by default on a table, it'll come from a shared bucket. So the capacity that you consume each second, has to be divided across all readers. So it's not, the answer must be something beyond just a direct read to the table.
Yeah. We have to do something where we have a separate bucket of capacity. And so we just talked about indexes. GSIs, one of the advantages of GSIs is they're a separate bucket of capacity. So I can have my base table, taking reads and writes, and then I can have an index. Now, usually you use GSIs to have a different access pattern for your items. You have a different partition key and sort key. But you know what? Nothing says that you can't have the same partition key and sort key, in which case you've kind of just had a second copy of your data ready for you to give that pointer. It's kind of like in a relational database where you have a read replica. It's the same data, but it's just isolated over there. And you can bang against that one without worrying about what's going on in the main one. So yes, this can do it. You can basically give the downstream consumer access to the GSI, but at what cost?
That's nice. Hey, Jason, that almost sounds like an LSI in that case, right? That may be a preferred way to set up like the same keys in an index, but avoid some of the, inflexibility of an LSI.
Yeah. A lot of times people think you have to use an LSI if you have the same partition key, but that's not true. You can do a GSI with the same partition key. And this is one reason to do it. The downside of the GSI is it copies your data. It's like a shadow table that replicates from the base table. So you've got another storage bucket, you've got more writes, and then you've got the reads that can go against it. So it's not something you want to do lightly, but it's good to understand that this kind of thing is possible. Mm-hmm. If I did it, this is kind of an advanced question. Should I auto scale my read capacity on the GSI?
Meaning, should you turn on the automation to like raise and lower the read level that you pay for?
The auto scaling so that it raises in response to demand and lowers after demand. I think the answer to this one's kind of surprising. I would say no. I would say no, because you're probably going to want to say, like, I want the downstream consumer to get 2,000 reads a second. I'll let them go exactly up to the 2,000, no more, no less. And that way I don't have to have any of the padding that is usually associated with auto scaling, where if they use 2,000, I'll try to move it up to like 3,000 to give them a little bit of headroom. They're just going to consume a flat rate, and therefore I get 100% utilization, which is the most affordable because I have nothing wasted. So I'd say, like, all right, downstream, you're going to get X amount, go for it. I might let it scale down below that, but I'll probably max it up something low so that I have no wastage on the top. But
that's nice. I love it when people they build a bulk job and they already know their velocity from some testing, and then they can provision just the perfect amount of capacity. And
right. If you provision exactly what you use, then you've wasted nothing. It's like you buy the cream for your coffee and you do the last drop on the last day before you fly out. I just love it when I can do that. I hate to have like one day of coffee and I need the cream. Any other uses for this GSI design? You know what? I've seen people use GSIs like this to have extra read capacity. So the base table gives you, say, 3,000 read capacity units on any particular item, right? At the most, if it's maximally splits. But what if I want 6,000? If you have a GSI and you randomly pick between the base table and the GSI, now you've got 6,000 read capacity units, even for a single item, because you've kind of replicated it. And that's a way to scale up. It's an advanced move. It's not something you want to do every day, but kind of interesting to know about.
Oh man, yeah, that's pretty cool. You could even have 2 GSIs and get 9,000.
Yeah.
Yep.
Here's another puzzle. I want to sample 1,000 random items from my table. How would I do that? Why would I do that, Rob?
Oh, sorry. What if you have just a huge table and you want to sample it as data scientists, get some idea of like what kind of data is in the table, what are some of the average values? You don't want to start at the beginning of the table because maybe you always start there. Yeah.
I think especially a schema check where people say, what is the schema of my table? You kind of need to sample it because there's no enforced schema. There's not a external definition like relational databases have.
Yeah.
So how do I do it? There's your challenge. I got asked this, and someone's like, "How do I get 1,000 random?" You kind of want to do like select, sort by random, but you can't do it.
Yeah, you wouldn't want to look at the whole table and then pick random ones. That would be pretty slow. But
that would be extremely slow. That would be the wrong answer.
The wrong answer. You'd be waiting forever. But don't we have a feature like parallel scan that could maybe divide up the scan into different sections, like slices of a pizza?
Exactly. So, what is a scan? A scan is where you go against your table and you're just going to start at the beginning, go to the end. And there's a sort order. You're not going to know what it is, but you start at the beginning, it goes to the end. So if you ask for the first 1,000, you get 1,000, but it's not very random because if they all have the same partition key, you're going to get like 1,000 items from the same partition key. If that's one user, you're going to get 1,000 items from that user. It's not going to be at all random. And so what you were talking about is the parallel scan or segmented scan, which I actually have a graphic for it. On the back of DynamoDB, we have these partitions. They're the actual holders of the data. If you know DynamoDB, you hear a lot about this. Each one has like 3,000 RCU, 1,000 WCU. And you don't really know how many there are, and you don't really care. But when you do a parallel or segmented scan, you divide that table space into n many items, 10 here. And each of those little consumers could like start at the first one or the second one or the third one. It's not really related to the partitions. So if you did this and you had 1,000 segments, you'd kind of get 1,000 random positions in the table to pull from.
Yeah,
right?
that would work. Mm-hmm.
So that's kind of good, I think. How many total segments can we use with a parallel scan? That's trivia, Rob. Do you know that one?
A huge number, like 1 million, isn't that right?
It is exactly 1 million. And so I could do 1 million points, and then I could pick 1,000 from that 1 million points, kind of. Or I could use limit. Now, who remembers in the audience what a limit is? A limit is where you say read here and read up to n many, the limit of 10. So I have 1 million possible start points. I could read maybe 10 items at each. And then I could like pick a random start point and a random number to read. And now I've got, say, 1,000 out of the 10 million. And I bring this up because it's actually important to know how DynamoDB scales. Because if you're going to do any sort of bulk activity, what you don't want to do, since most DynamoDB tables are really big, you see hundreds of terabytes often, you don't want to think, I'm going to do a simple scan starting at the beginning, going to the end. These tables are massive. So the idea is that you want to do a segmented scan. You have a lot of different clients, each processing their portion of the table. And so this is a fun way to understand how at least if you're a database nerd, it's fun.
I like it because you can, decide if you want to process 10 records at a time, it's super easy to do that. And maybe that's the velocity that, you prefer to read at. Yeah. Sound
good? All right, let's talk about bulk update. I see this a lot with customers. And so I get asked this regularly. I want a bulk update, maybe delete a good chunk of items. Is there an easy way to do this? No downtime allowed. In relational, you do like an update.
Update set salary equals salary times 1.1 with no where clause, and just press enter and let the database do all the work. I don't know if I like that because that could take 5 hours. It might never finish, right? It might steal all the cycles from the server from other users.
So just do where username equals JSON, please. That'll be very efficient.
Nice.
All right. So what do we do in Dynamo if it's like this? We have these bulk processing things, right? EMR, Elastic MapReduce, Glue, Spark related. Those are good for bulk, right?
Those are good.
I like those. And in fact, here's a blog that you can just Google on the words if you want to see it, which is backfilling the time to live. Remember, time to live was the one where there's a time that you can delete. And so maybe I want to update that based on some other attribute to set the right TTL. This does it in bulk. But in the blog, little thing, this technique works best for insert-only workloads or during periods of maintenance when the updates or deletes aren't allowed. And why is that? That's because it does a read, makes decisions, and then does a write. And so if you've changed anything between the time it does the big read and it does the big write, they kind of don't matter. Like if you're going to update based on an attribute, maybe the attribute changed between the read and the write, you're going to lose that. So that's the challenge with this kind of thing. So something that happens sometimes is you actually want to do a real live code-driven condition expression, control when it runs, that kind of thing. And it's common enough that I wanted to bring it up because this is a real puzzler for people. Like I have a giant table. How do I, easily do this? And so I wanted to work through it. So like, let's do a mental puzzle. I'm going to do a single threaded full table scan. I'm going to read some items. I'm going to update some of them. How fast would that run?
Well, I think the scan part, of course, DynamoDB doesn't really accept unbounded work, like I talked about in the other example, to update everyone's salary. So if you try to scan, you would be stopped after a megabyte. You'd get to your first page, as it were, megabyte of data back, and then you'd have to request a second one. So that's one thing that could slow you down a bit.
So yeah, you got to read in megabyte chunks. That's a slow thing. Let's say that I'm very good at reading my megabyte chunks. I have low latency. What's the next bottleneck I hit?
The amount of read capacity. If it's a provisioned capacity table, then you're going to be stopped every second. It'll measure how much fast you're going and then stop you if you go beyond that level of reads.
Right. The first thing you're probably going to hit, well, is it going to be reads or writes? Let's assume it's going to be writes. Let's say I try to delete all the items. You're first going to be hitting, like when you do the scan, remember you're first hitting that first partition. Each partition gets 3,000 RCUs, 1,000 WCUs. So if I'm deleting them all, I'm probably going to be hitting the write limit first. And I see this. I see customers saying, like, scans are really slow. And I'm thinking, well, they don't have to be. It's just if you do it front to back, you've got all those partitions ready to do things that you're not using. You're focusing all your attention on one partition. By default, you're going to be doing 1,000 write units as the limit. But if I do reads, like let's say I'm only updating 1% of my items, and I'm probably going to be read limited by reading about 3,000, which is still fast. It's 24 megabytes per second. Don't ask me how I know that, but that's the amount that you're going to maximally read from one partition. It's pretty fast, but it's not like as fast as you'd want for a giant table. So what's the solution, Rob?
Well, if you think holistically, right, you might purchase some extra capacity or some reserved capacity, right? And if you don't use all that in a period, you could use that like in your idle times to do some of this bulk work. Is that what you're thinking?
That's not going to make it any faster, though. To make it faster, actually, even more motivation. Does this bottleneck have any negative impact beyond slowing our speed? Yeah, if you consume all the read-to-write capacity from one partition, everybody else trying to do things on that partition risk throttles. Throttles are when you do a request and it says you've already used all your capacity for this 1 second, try again. And so you have a noisy neighbor effect, which you'll know about in the office where you can hear the people in the room next to you. It's that kind of thing, where I'm so consuming capacity here with my work that I'm hurting someone else's. So you really don't want to do this. The parallel scan that we talked about before. All right, so let's say I do a parallel scan with 10 threads. Does that help?
Oh, right. Yeah. I think, well, now you have 10 workers working, so it's 10 times faster, but each thread still might go too fast and sort of have too much heat on a single partition. But yeah, considering we can do up to 1 million, I think we could just make it very, very parallel and get a lot of workers, and also use the limit maybe to not process too many at any one time.
True. The way I picture it is like the first one was a laser beam of light where all the light energy is on like that one partition moving through it before it moves to the next one. What we do here is we have 10 laser beams. So we're still throttling people, but now we're throttling more. Is that better? Maybe not, because now I've got 10 places that are throttling instead of just a single one. And you could do 1 million, but now it's like 1 million laser beams. I guess with enough laser beams, it's like not lasers anymore. Maybe that's your argument. I actually have an approach here to eliminate the bottlenecks, and I call it a shuffle scan. So you ready?
Let's see.
I did a deck of cards because it reminds me of shuffling. So basically, like if I have a deck of cards and I want to shuffle it in an algorithmic way, what you do is you pick a location, you pull a couple cards, you pick a location, you pull a couple cards, and you do that over and over. And if you make a new pile, you'll have a mostly shuffled deck, or at least it'll look mostly shuffled. Maybe you pick 3 cards at a time because you're lazy and don't want to do like a single card. All right, so that's the basic idea. So you make a parallel scan with a lot of segments, maybe 1 million, I don't care. A lot of segments, probably do 1,000. You pick a random segment and you pull a few items from it. Pick another segment, pull a few items from it, over and over and over. What you've got now is a stream of items coming out the other side, which are scattered around the whole table. And if you proceed tracking your last evaluated key, do you remember last evaluated keys, Rob?
Yeah, I think for each scan, if there's more to come, it'll give you this bookmark, the LEK, and then if you're at the end of the scan, then you'll see no LEK.
Exactly. It's your but wait, there's more to be continued at the end of your scan call, just like a TV show. And when that's done, you're at the end of the season or at the end of the show. And so you do that until every segment you're pulling from has said, I'm done, and I've got a new pile. And this approach is how you can take billions of items, trillions of items, some people have, and actually not create laser beams of light because it just is pulling from the entire table space. That's why I did the whole, how do I pick random items earlier, because it's used here for this kind of thing. And so, I'm bringing things.
I like the distributor model, right? Like in your car's engine, there's a distributor that sends a spark to all the spark plugs, but not all at once. Like it goes in turn, like round robin. I think that would help to give the right velocity to each worker.
You got it. All right, let's talk money.
Money.
Good section. This was a real question. this customer, would like assistance in ways to estimate and reduce the cost when modifying a single attribute on about 550 billion DynamoDB items. I remember getting this and thinking, well, this is going to be a fun one. That's a puzzler right there. Like, what do you do? How do you update 550 billion items affordably? And the reason I say affordably is anything times 550 billion is big. You know, and so they're trying to save costs by deleting some items in their table. But if you do this in, you know, a simplistic way, the tiny cost of a write times 550 billion is still something. And so that's why they came to us. And I was kind of pleased that I had a good solution. So I want to share it with people here. And the one that they went with was to use reserved capacity. Do you remember what reserved capacity is? RC?
RC, yeah. This is not to be confused with provision capacity, but reserved is a thing that you'd buy maybe once a year where, you know, you have a lot of tables. They're in the provision capacity mode, not on-demand mode. And you figure out like how much you're paying for all those read and write units on average, or, you know, the floor level. And you can talk to your account team and, you know, buy one of these reserved capacity plans, kind of like buying Amazon Prime. If you know you're going to use it consistently, then it's a great deal because you get a nice steep discount on your rates for those read and write units.
Yeah, good analogy. I think of it as like Costco eggs, where you have to buy 2 dozen, but they're so cheap. It's like 2 dozen for the price of 1 dozen. So even if I'm only going to use 18 eggs, I'm winning. I mean, in a sense, if I use 13 eggs, I'm winning, right? And it's very similar because reserved capacity is a promise to consume a certain minimum amount for 1 year or 3 years. You know, and the promise is because if you don't consume it, you're still charged like you do. But you get a discount, a little over 50% for 1 year and around 80% for 3 years, right? So you get a major discount of your provision capacity if you buy reserved capacity. And so people who are using DynamoDB heavily will oftentimes turn to this as a way to say, this is a great way for us to, you know, manage our costs, cut our costs. And it's just like the Costco thing. If you're going to use anywhere between 12 and 24 eggs, because the eggs are half the price, you're winning. You don't want to go to the shop and buy 2 individual dozen. So what does that have to do with bulk updates, Rob?
Well, it's I think the strategy therefore is to buy extra eggs, right? Buy a little bit more than you might need because you may grow into it, but you also, I think, have this extra bucket of capacity that you've paid for at a discount that you could turn around and you know, apply to these bulk update jobs to try to update the 550 billion items in using the spare capacity. Is that right?
Right. It's like I bought the eggs. It was use it or lose it. They're starting to go bad. I'm not going to eat them. So now I have eggs to play with. Let's go egg someone's house. It's that kind of thing. And most of the time you want to buy more than your minimum. You know, if you have a daily sine wave, you want to buy more than the minimum because the time above the minimum, you want to keep getting some savings. Generally, you do kind of in the midpoint. And so you have some. Now, if you're curious about what the right amount of reserve capacity is, if you're not already using reserve capacity, here's a link, the bit.ly Recode tool, which is the recommendation engine for reserve capacity. It looks at your last 30 days and says, this would have been the right amount of reserve capacity to own. So if your future looks like your past, this is great advice. You know, maybe your future is going to go up. Maybe you want to buy a little more, but it's at least able to say, this would have been perfect for last month. Generally, it's a little bit above the minimum, which means if you own reserve capacity, you probably are having some use it or lose it where you're losing it. Let's do our writes during the lose it phase. All right, so here's an actual customer kind of chart where I have the daily traffic, 300,000 up to 650,000. That's consumed write capacity units. So it is fun to think about. They're writing every second 650 megabytes of data. And they might say that I'm going to reserve 500,000. That's just the way that we've allocated here. All the distance between that horizontal line below it to the orange line is the lose it of the use it or lose it. Still a good buy because the discount is so great. But I could fill in the gap there with my bulk writes and get those bulk writes free.
Oh, that'd be sweet. They need to be really well optimized and efficient.
Yeah, the customer liked free, 550 billion items updated for free. It is not without challenges because you have to figure out when am I below the line. And when you're doing reserve capacity, it's not just for a table, which is good for you. It's across all tables in a region under one payer account. So it's even across accounts. It's just this payer account buys reserved capacity and it gets allocated to any tables in that region related to that payer account. So you have to look at like the histories is the easiest way to do it, and say between 2 and 3 a.m. I'm below like this, between 3 and 4 a.m. I'm below like this. And now you know the amount that you're usually, saying that was expected unused capacity. Well, now you can use it with reserved capacity. Right? Nice. And all right, so now that I know that I want to burn 100,000 for a while, how do I make sure, like if I'm doing deletes, how do I know I'm consuming 100,000?
Well, I guess you don't really know how much the delete is because you don't know the size of the item, perhaps. But you can, isn't there a flag, Jason, where you can say, hey, show me the cost of this delete I did, return on reserved, return consumed capacity, and you can see how many WCUs were consumed, and then you could perhaps add that up and see like how fast you're going.
Yeah, how are deletes priced? They're priced as the size of the item being deleted, which you don't know when you ask for the delete, probably. Like delete that item, I don't know how big it is. So you can add to the request and let me know how much that cost. And it'll say that cost 4 WCUs, indicating that, oh, the item must have been about 4 KB. And so you can keep track that way and just keep a running tally of how fast you're running and everything like that. So not everyone knows about that, so I wanted to share that. You have the ability to ask on a big complex request, how much did that cost? Good to do cost management, but also good to do rate limiting.
I like it, Jason, for filters. Anytime you're doing a filter operation, like you don't really know how big your item collection was before the filter, right? And so that's a hint that, maybe your filter is visiting 100 records, but only finding 3, right?
All right, so what's the filter, Rob?
Filter, I think of it like, it's like a third thing in the where clause. So we have a partition key, we probably have a sort key. Those are really efficient ways to sort of slice the table into sections. And after you've exhausted those two, then, if you want to do a third sort of search condition in the same request, we can do that on the server side for you in DynamoDB, but you pay before the filter starts. So if you're reading 100 items to knock out 97, the filter will do the work, return you the 3 that you want, but you'll pay for the size of the data before the filter started.
Right. It's not the most efficient, but it can be convenient to have the server do it for you, and it's less on the network. But you're basically saying just right before it sends it to you, apply a filter to see if you should get it, but you're going to pay for the pre-filtered size. So you want to use indexes wherever you can, but filters are handy when you don't have an index available. And so then there's a blog here, cost-effective bulk processing. It actually shows 3 approaches. The reserved capacity is just one. There's a couple other ones that you could use if you want to do really massive scale. Less than 1 billion items, but above 1 billion items, yeah, you're going to want to bring out the creative approaches to get the writes done. Because what's unique about bulk processing is you don't really care when it's done. Just get it done eventually, which means we can pick the time of doing it. And if we can pick the time, then we can be creative, right? If you want to do writes the moment that a user's checking out a shopping cart, well, now you don't want to delay that, and so you don't have the same bulk effect.
Nice.
And if you want to do like a massive delete, here's another newer blog. This one just came out less than a month ago, which is using step functions and a bunch of lambdas. Because the challenge is if I have 1 billion items, how do I try to quickly do it? This one farms it out to a bunch of lambdas that just tackle the problem in parallel, purely serverless, which is really fun these days when you can update 1 billion items and not actually see a server anywhere in the picture. So I wanted to send that up to people. So there's a title you can search for by Chris Gillespie, friend of mine. All right, if anyone has sort of nerdy questions, feel free to write in the chat. But timing matters. All right, timing. This one really was a puzzle. This one puzzled a lot of us as we were like, what? That can't happen. I configured 30,000 WCUs. So when I provisioned a table of 30,000 WCUs, I see a lot of throttles, and CloudWatch is showing that I'm consuming just 2,500 WCUs. Now, 30,000 is much bigger than 2,500. So I don't expect I'm going to be seeing a lot of throttles. So you think, right. There's a throttle at a partition level or something like that. Sort key, but no, The partition key is a UUID, a unique identifier. There's no sort key, and it's an insert-only workload. That is the definition of should not do any partition level throttles. This is a table level throttle. Why?
Yeah, I love the pattern of using UUID and no sort key is sort of our original key value, where data is we shard the data everywhere, and you shouldn't expect any hotkeys in that sense. So this one, I think, it'd be puzzling at first because CloudWatch is trailing that you're going well below 30,000 writes.
I bet if I just asked you and you didn't already know the answer, you'd be like, oh, Jason asked a question. I don't know. Am I right? Because this one's really confusing. You know the answer. But I bet we wouldn't otherwise. And here's proof. You're like, nah, it's not true. So let's go to CloudWatch. CloudWatch shows it. Yeah, 2,500 right there. Huh.
Now there's a clue. Look very carefully at this chart all around it. I think there's a clue as to what's going on here.
I'm going to zoom in on the clue.
What do we know about CloudWatch?
Nearly nothing. it's magic.
It's magic. What's the lowest resolution we can get to? Can we do it per second with DynamoDB capacity?
These things do not write at a per second. They write at a per minute basis, which is interesting. They write at a per minute basis, but the usage is on a per second measurement. So what does that mean? It's like, it's like I'm jumping out of a building and you tell me how far I moved in the minute. And you're like, he should be fine. But you didn't actually measure that, I jumped and fell on the floor and broke a leg.
Yeah, your average
really matters
is like 2 miles an hour. That's fine, right?
Average was just fine. And that's exactly it. What the 2,500 per second really means is that there are 150,000 during that minute, which will display as 2,500. But what if the 150,000 all came at the top of the minute? Which is actually what the problem was. It was so weird because it looks just fine. And you imagine, oh, well, normally data's smooth throughout the second or the minute. But no, at the top of every minute, they did 150,000 and they got throttles. And why did they get throttles? Because the table is provisioned at 30,000 and 150,000 is much bigger than 30,000. But, we have burst capacity. I don't know if people in the audience know what burst capacity is about. With burst capacity, it allows you to consume a little bit more than provisioned for a little bit. So you'd think the burst capacity would handle this. But the problem is, the table only had a physical capability of 30,000 a second because it was only provisioned for that level as its max ever. And so the burst didn't really have the ability to do any more bursting. And so that's what it was. So it took them about 5 seconds to get done. They saw a lot of throttles during those 5 seconds. And what's the fix, though? And this is kind of interesting. There was a fix that was easy. The obvious fix is provision 150,000. But customers never like it when you say, please spend 5 times as much.
Yeah. Plus, you'll be wasting it the rest of the minute.
Right. 1 second good, 59 seconds boring. What the fix actually was? Yeah, go.
Maybe just don't be so sudden and spiky, right? Just spread the traffic out throughout the minute. Slow down, do some sleep functions if you need to, but try to get the traffic to be more evenly distributed throughout time.
Well, yes and no. I say yes and no because that's kind of what they're getting with the throttles. You're trying to do 150,000, 30,000 succeed, and 120,000 are told, wait a sec. 120,000 tried, they're told, wait a sec, but 30,000 got in. And so over 5 seconds, they all got done. You could be polite and say, instead of having me throttle you, come more smoothly. Like instead of everyone coming for dinner at 7 o'clock, come later. But it's the same effect as if I had a long queue out my restaurant, right? Here's the actual fix that might surprise someone. You temporarily increase it to 150,000. And then you put it back to 30,000. And why did that do anything?
Well, I guess the knobs, you can dial up, you can turn up the table and say, now I want 150,000 writes per second, and it should have no trouble after that is set.
It made burst capacity work. Because now that first second, it could burst 250,000 because you had more physical capability in the table. So it would burst really big for that 1 second. And then burst capacity is like you use it up, but then it restores itself. So it would all get burned that first second. And then you had 59 seconds more to restore the burst capacity. And then it could all be consumed again. Once you had made the table big enough, it didn't naturally grow because it only saw these 5-second bursts of traffic. So it's like, wow, that was over quick. And it doesn't naturally expand. If the traffic had been sustained, the table would have expanded itself normally. But when it's really spiked for a couple seconds and leaves, it doesn't have enough time to decide to grow. So you force it big, set it back small, then it worked. And the customer was like, so I just do that and it's all gone? It was really weird. You can imagine from a customer, like, scale big, scale down. Now it's good. And if you didn't know what was going on in the back end, it seems like magic, which is why I thought, that'd be fun for the Puzzlers talk. I like things that feel like magic.
That's awesome.
All right.
Jason, should we just mention what is burst exactly? Because it's kind of an interesting concept, right?
Sure, go for it.
Well, burst is a thing in DynamoDB that if you've been good for some time, like meaning not using all your provision capacity, then you can burst or go above what you're paid for a few minutes after a spike like that. So it's sort of a window. We have an algorithm called a token bucket algorithm where we sort of measure how much below or above your paid level you are, and you earn credits and you get demerits, I suppose, for going over your capacity. So you can sort of borrow from past underutilization, and we'll apply that for up to 5 minutes to handle spikes as best as we can, like we saw in the example.
It's like a cash advance is how I describe it. You get 300 times your provisioned level, which is where the 5 minutes comes from, as something that you can burn down when you go over your provisioned amount. Once you burned it all, then you're definitely throttled at the provision level. When you're below provisioned, it's like paying off your cash advance. And you can live forever with 0 things in your cash advance balance, but that's what works. All right. In the chat, there is a link for a survey. So those of you who have stuck with us all the way through the meat and potatoes portion of this talk, we're going to end with some dessert things. But go quick, because the first 50 people get $20 in AWS credits. So be one of the first 50 to fill this out. And you get dessert credits. Should be $20 for like cheesecake.
Nice.
Right.
Yeah, let us know your thoughts. We'd love to see like what we'd like to hear about next time, how we can do better.
Exactly. All right, let's think desserts. I have pitter on a large table. Someone ran a bad bulk job Monday at noon and deleted important items. How can I recover? First of all, what the heck is pitter?
Pitter.
And for this one, there's another survey.
It sounds funny, but
it is penguins in tiny rockets, partitions in the restore. That sounds pretty good. Oh, it's the sound the little feet make, pitter patter. Papers I tried reading. I got a lot of those. Or point in time recovery. The winner is little feet so far. Anyway,
pitter patter.
It's the pitter patter. That's number 5. Point in time recovery. The idea of pitter is that you can just turn on the flag and say, I want the ability to go back in time and restore the table as it used to be. You can pick any second from the time you turned on pitter to now, up to 35 days ago. And it's just your lifeline. It's like, I can't believe I did that. Well, I think we've all had that moment where we delete something we weren't supposed to, overwrite something we weren't supposed to. And pitter lets you save your bacon. Now, what normally you do with pitter is a full table restore. That's what it was designed for, point in time restore. So you pick a time and you restore the table, which is good, and you get the table before the mistake. But the downside of it is that the bigger your table, the more this costs, because you're charged on restores by the gigabyte. And so the worst case always seemed to me like I deleted one item and I just want that important item back. How do I get that back? Like I have to restore the entire table to go get that one item. So is there anything better for that? And my hint is don't do a restore, do an export. Got an idea, Rob?
Ooh, yeah, I think restoring the whole table could could take forever. It'd be hard to work with that. Export, yeah, I think there's this export feature, isn't there, Jason? So if you have the Pitter data protection service turned on, then you can also press a button and dump the whole table into your S3 bucket. And that's now it's your data to look at and analyze, and it's almost like a little data lake. But even that's big too. If you do a full export, that's going to take about as long as, and then backup or a restore. So might not be the best solution.
And the cost too.
Yeah.
Right. So that's the next thing. Don't do what you just said, Rob. Don't do a full export.
Yeah. Don't listen to me.
That's not what we were supposed to learn today. Don't listen to Rob. Do listen to Rob. Rob has a better idea coming up. So what's the opposite or what's the alternative to a full export?
Yeah. Well, there's a great thing, the incremental export. I think that's going to save us because how does that work? Is that kind of like a normal export, or?
You pick a time window and you say, give me the changes that happened between these 2 points. And so if you make a mistake at a certain time, you can say, show me the changes that happened during my mistake time. And from that, you can say, oh, I see what the item used to be like and the fact that it was deleted, so I can go save myself.
Nice. It's almost like a little log analyzer or a log slicer where you can just carve up the daily log and look at that. It could be like way less expensive than trying to export everything.
Dramatically so for small recoveries. Like if you mess up your table big time, you might just want to restore and say, well, it's a mess. But if you, did a few items here and there and you just want to undo it, this is what you do. You do an incremental export of like the time range in question. You get an old image and a new image. I'll show you here. And now you can undo it. So what's the cost savings on a 100 terabyte table? Well, a restore, what's that, 15 cents a gigabyte?
15 cents, yep, per gigabyte.
So that's $15,000. How much is an incremental export of an hour? $1 maybe?
$1, yeah.
So I think we earned our keep for this talk, Rob. If someone has this need, that's a dramatically better way to go. You can do it on the console here. This is an incremental export. You go to this date, this time to here, go. And what you get out looks like code, but it's basically old and new. So we see that at this time, Mary Grace became Mary Smith. If you want to undo that, you say, never mind. Mary Smith is back to Mary Grace. And you see all the changes. Like you said, it's a log analyzer. So you can basically go to logs and it shows you the old and the new. And you can undo it. Instead of the old going to new, you can make the new into the old.
That's nice.
Yeah. And then here's another cost-saving dessert. I want a cross-region disaster recovery, which means, I have all my great data in one region, US East 1, US East 2, US West 2, something like that. But I'm saying, what if something goes wrong in that region? Anything goes wrong. It could be my code, could be some dependent service, Lambda, it could be DynamoDB. Something makes me want to evacuate that region, go to another one. And you know what? I'm okay with a high RTO RPO. What is RTO RPO? We should have a poll for this.
These are interview questions.
They are. Everyone will pass the interviews after this. Recovery point objective, which is how stale you're okay with your recovery point being. And recovery time objective, which is how much time you're willing to devote to the restoration. So if I have a 6-hour RPO, it means any changes in the last 6 hours, if I lose them, it's fine. And if it takes me 6 hours to get going, that's okay. I need it back, but I don't need it like immediately back. Is there a low cost option? Because the high RTO RPO means maybe I have an option for cost savings. So what do I think of when I think DR? I think global tables.
Yeah, that's like our premier sort of data, replication. The RPO and RTO are both close to zero. That's so it's
instant,
definitely
active.
Yeah,
that's good. But what do I pay for? Well, I have double the storage. I have double the writes, maybe triple if I did 3 regions, and each write costs a little bit extra. So I more than double my cost when I do global tables. And maybe I want like really cheap because I have that 6-hour RTO RPO.
Yeah,
this is good when you say, I want to keep going.
Yeah. Well, what if we just learned about the incremental export? Would that help?
I got other options first.
Okay, let's see what else.
Pitter with cross-region restore. So Pitter when I restore, I can point this region to that region and say, restore over there.
Hmm.
And that's good, except
if the region's gone.
Yeah, if the region's gone, you don't have a place to start from. So it really depends on the set of disasters you're worried about. If you're worried that maybe your IAM deployment messed up, a lot of times, the region goes bad because of a human deployment error. You could use this. But if you're saying, maybe I want that the whole region got flooded with some hurricane and I want to be able to still be fine, then that's not going to do you because your data is underwater. What about AWS backup? I can do an on-demand backup. I can proactively copy it to another region. Now it's in the new region, the dry region. I can restore there. What do you think?
That's nice. That reminds me of the old days, Jason, where I used to take tape backups once a night from the servers and put them all into a box, put the box on a truck and drive the truck far away. And then I could go sleep well at night knowing that my tapes were far away from any like floods or fires that might happen to the data center.
Did you do the driving?
No, we put them in an Iron Mountain truck, I think.
Oh yeah, there you go. That's pretty common.
Yeah.
Yeah, that's that basic idea. You do a backup, but what's wrong with it is you need a big truck for big tables.
Yeah.
Because it's only on-demand backup. There's no incremental backup. So you have to, for a 1 gigabyte table, this is great. For a 100 terabyte table, to do that on-demand backup and copy, you have to, pay by the gigabyte for the backup and pay by the gigabyte for the transfer. You really want an incremental backup. And maybe someday, but not today. But you have today an incremental export, which is like a backup. It's a plain text JSON formatted backup. So that's my advice. Think about incremental export, which was not created for this. This is like an off-label use of it. But if you want to continuously maintain what's been changing and ship those changes elsewhere so that they could be replayed, you can do this. And on the receiving end, you don't necessarily even need to have the table created if you're ready to make the table on demand. That depends on your RTO. How long do you have to get live in the other region? If it's like 10 minutes, you better have a hot table, right? But if you got 6 hours, maybe say, I'll make the table, I'll load it, I'll be ready by the time I need to be in business again. So it really depends on your RTO, RPO when you're doing disaster recovery setup. But you have a new thing here with incremental export.
That's
and
nice.
I did a little math. I have a 10 terabyte table. All right, well, what's the cost of a backup? What's it, 10 cents per gigabyte? So that's about $1,000, right? I wouldn't want to do that too often. But if I have a 10 terabyte table that accumulates about a gigabyte of logs every 4 hours, because when you do an incremental export, the cost is based on the log size you're analyzing. If I do 10 cents per gigabyte exported at 6 per day, and I'm doing 1 gigabyte, that's 60 cents a day. And if I transmit at 2 cents a gigabyte and we compress them, so like they're 1 cent every time, is going to be about 6 cents. So for 66 cents a day, I can keep a copy of my 10 terabyte table incrementing every 4 hours to the other side, ready to go.
Oh man, that's really nice. Yeah, and it's super efficient. We're not just moving terabytes every day when there's no disaster. We're just moving just what's changed. So yeah, it could cost pennies. Mm-hmm.
Exactly. So I call that dessert because that's kind of fun. So what do we cover? RCUs and WCUs, right? Read and write capacity, global tables, what they're for, TTL, condition expressions, scans and parallel scans, CloudWatch, be careful with periods, the bulk update, reserve capacity, limits on your table and your partitions, on-demand pitter backups, and some creative uses of incremental exports and their off-label uses. And if people had questions now or whatnot, hit them in the chat. Here's another chance to get that $20 AWS credit. First 50 people that do it. There's a bit.ly link or scan the QR code if you can. Someone asked about epoch time on TTL. Yeah, the way TTL works is you have an attribute. You give us the name of the attribute, and you say, this is my TTL attribute, and then you put in there a number, which is the second since epoch time, and after that time is when that item is eligible for deletion.
Yeah.
And that's just the way that it goes.
I think the question is like, why not another format? DynamoDB doesn't have a native date format, but we do have strings and numbers. So, you're free. A lot of times people will put their dates in string format in that ISO hierarchical format. But it should be pretty straightforward to have like a little piece of code that converts one to the other. Seeing that TTL does require the epoch format.
Yep. Anything else about deletes? Any other questions?
There was a question, Jason, about rename table. We don't have that today, do we?
Not today.
Not today.
It's a trick, right? The best I can tell you right now is don't name your table something like US East 1, because maybe you're going to make it global later. You're going to wish you didn't. So be careful putting anything transient in a table name, because table names are permanent.
I like to tell my customers, in your stack, just make that something that's easily configurable. Like the name of the table, put that in a config file, or use AWS config, so that, if you have to restore to table 2, then you can quickly point to that without making a code change.
Right. And how fast does a TTL delete? It is free, which means that we get to do it at a time when the service is a little bit idle. The places where the data is stored, the storage nodes, they say, oh, I have a little bit of extra capacity to do a bit of work, so I'll do some TTL deletes, which means that it's not that second. If you want it effectively done that second, you apply a filter expression that we talked about, which says, and filter away items that are no longer live, putting a filter on the TTL attribute, but they will get done. But there's not an instantaneous aspect to it, except in global tables, where one region will decide to do the free delete, and then it will immediately propagate to the other, because we want the global tables to be fully synchronized with each other, always kept as close as possible, so we don't let them independently float.
Mm-hmm.
All right. Any last question? Happy to take it. Otherwise, I'll be back in 4 weeks. We'll do more about, I think DynamoDB is the plan in 4 weeks. Next week, we have relational and zero ETL with Aditya, who's a bud of mine, and talk about how you can move from relational databases and Aurora into Redshift. So that'll be at the same time 1 week from now.
It's all about data.
It is all about data.
Awesome.
It's a data dive. It's
Love
a deep data dive. Something like that. All right.
Thanks for coming.
I hope you DynamoDB people learned something. We covered quite a lot. I hope the people who don't know DynamoDB stuck to the end, because we're just so funny. Thanks, everybody. See you in a week, and see you in 4 weeks.